Hey guys, this is our new section of Chapter 10. We are talking about conic sections. So a conic section simply is just the intersection of a plane of a double-naped cone. So a double-naped cone is just when you put two cones on top of each other, but these are all the different intersections you could find. So we've talked about circles before, they're going to come up again. We'll talk about ellipse, parabola, and hyperbola. All conic sections will take on some form of this equation down here, and each conic section can be defined as a locus or collection of points satisfying a geometric property, i.e. a circle is a set of all points equidistant from a fixed point. So you're going to see that in their definitions. Today we're focused in on parabolas. So we're going to take a look at just the definition of parabola and then all the different pieces of a parabola. So a parabola is a set of all points in a plane that are equidistant from a fixed line, which is called the directrix, and a fixed point, which is called the focus, that is not on the line. The focus, again, is the point inside. So I'm just going to highlight here and color code it. I already color coded it in the picture, but all the green dots are the what we call the foci, or the singular of the focus. The directrix is the line that is outside of the parabola, so that is the red line there. If you notice, it has the same distance to get from the yellow point to the green point and from the yellow point to the red point, and that's going to be important for us. The axis of symmetry is the blue line. It's just the line that divides the parabola symmetrically. It always is going to go through the vertex and it'll run perpendicular to the directrix. And then the last one, the yellow one, is the vertex. The vertex is the point where the parabola intersects the axis of symmetry. So when we talk about these, what I'm going to talk to you a big deal about is what's in control. So if you look at, we have two different equations here, one where y is squared and one where x is squared. And depending on whether y is squared or x is squared is going to tell you what direction it faces. So what I pay attention to is it's the degree, the variable that's to degree 1. That's going to tell you what's in control in the problem, meaning what direction it's going to face. So I'm going to write that out. The variable with degree 1 is in control of the direction it faces. So that's how you're going to know what direction it faces. So if you look at the first picture, it tells us that this guy here tells us that the x is to the first degree, and if you notice, this is facing horizontally. It's facing in the x direction, versus the second equation has y as the first degree, and that means that this parabola is facing up and down. It's facing vertically. It's facing in the y direction. So then up at the top, you're going to notice a formula. That's the formula to help us find p, which is an important part here. So when you look at an equation, you have to remember that whatever the coefficient is, you have to set that equal to 4p. And that, once you solve for p, is going to tell you how far to move to find the focus and the directrix. To find the focus, you move in that direction, in the direction of that first degree variable. So since the first degree variable in my first one was x, I'm going to move in the x direction, p. And then to find the directrix, you just go in the opposite direction. So this was p, this is negative p. And then same thing for the y one. We move in the y direction. To find the focus, we move positive p. To find the directrix, we move negative p. So we're going to go ahead and go through some graphing examples. So if you look at number 1, the first thing I'm going to decide, just looking at it, is what's in control. Again, it's that first degree variable. So since x is to the first degree, I know right away x is in control. And then I'm going to go ahead and find p. I know 4p has to equal 8. And I'm going to divide by 4. So p is 2. For all the ones we're going to do today, the center is 0, 0. That's going to change at the next lesson. But the center is going to start at 0, 0. And then my p-value tells me I'm moving in the x direction, positive 2. Because x was in control, I'm moving in the x direction, positive 2. And then to find the directrix, I'm moving in the opposite direction. And I'm going to draw that dotted line through x equals negative 2. So I always graph them first, and then I go ahead and I fill in their values up at the top. So the focus coordinate points are over 2, up 0. And the directrix equation, that always needs to be an equation because it's a vertical line, it's going to be x equals -2. And then to finish graphing this, there is a trick here that I want to teach you, is if you look at this distance to go from the directrix to that focus point, that distance is 4. That's going to be the same distance we move out from the vertex to find 2 other points here to help us graph it. So this is also going to be 4. And then we're going to go this other direction, and that's going to be another point on the parabola. That's going to be 4. So then I'm going to graph that. This is my parabola. It's facing to the right in the positive x direction. But if you notice, the distance, the total distance that ends up happening here between those points is 8, which is the same value as what we originally had in the problem. So that's the other way you know those have to be 8 apart from each other. That only happens right at the focus point. If you're at a different point, that won't be the case. Alright, let's try another one. So looking at this one, the first thing, again, I pay attention to is what's in control in the problem. I try to sort that out right away for all the shapes we're going to talk about. So since y is the first degree, y is in control. And then I need to figure out what p is. So that's going to be 4p equals 20. And I'm dividing by 4. I get p is equal to 5. And I know we're going to start at 0, 0. And now I'm moving in the y direction, because y is in control. I'm going to move in the y direction, positive 5. 1, 2, 3, 4, 5. That's going to be my focus point. And then my directrix is going to go the other way. I'm 1, 2, 3, 4, 5. And I'm going to draw a dotted line through y equals -5. So then I can write down right away my focus point is over 0, up 5. And my directrix is y equals, because it's going through the y-axis, y equals -5. And then I need to figure out my other 2 points here. So I'm looking at this combined distance. All together, 5 plus 5, that makes that 10. So I'm going to swing out 10 here, and that's going to be 1 point, and I'm going to swing out 10 here, and that's going to be another point. And I'm going to draw my parabola. This one opens up much wider than the last one. Pretty much the bigger that number gets, the wider the parabola is going to be. So that's what your graph should look like for number 2. Alright, in number 3, the first thing we need to make sure happens is the coefficient is actually supposed to be over by the first degree polynomial. So the squared one, you actually want to be by itself. So you actually have a little bit of work to do here first. So note here that you need the squared variable by itself. The 4p is supposed to be over on the other side. So that means I'm going to have to multiply by -12 to the other side to solve this one out. So that's going to give me x squared equals -12y. So now if I look and see, I know that y is in control here. And I know I can find what p is by doing 4p equals -12 and dividing by 4. I get p is equal to -3, and this is the first one we've seen with -3. So let's see what happens here. We're going to start at 0, 0. And then the p tells me where I'm moving according to the direction of what's in control. So I'm moving -3 in the y direction. So the p, the focus point, is actually going to go down -3. That's always what you graph first. And then we're going to go back the other direction, and that's where the directrix will go. And then I can write down those coordinates. The focus is over 0, down -3. And the directrix is going through the y-axis, so it's y equals +3. And then I can find this distance to figure out my other points. That's 6, so I'm moving out 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I can draw my parabola. And if you notice here, it is actually facing in the -y direction. which is what we knew would happen because y was in control and the value, the coefficient, was negative, so it faces in the negative y direction. Alright, let's take a look at something a little different.